Okay, so I'm just going to run through some of these proofs. So the first one, prove that the diagonals of a parallelogram meet at right angles if and only if it is a rhombus. Okay, so let's draw up a parallelogram. Oops. Okay. Now, if this parallelogram is a rhombus, then we want to show that the diagonals meet at right angles. So we'll call that A and we'll call that B. We'll make them go in that direction. So if it is a parallelogram, if this is A, B, C, D, then DC would also equal A. So that would be A there. And BC would equal B. Now, if it is a rhombus, that means that the sides are equal. So therefore, the magnitude of A equals the magnitude of B, because the sides AB equals AD. So I want you to just realise that when you want the length of a side, you just put like this on the outside of your vector. If you just write AB, that just means the length of the AB, but that is the same as the magnitude of the vector AB, because it's the size of the length of that vector. Okay, so this side here equals this side here. And we're going to somehow use that in our proof. So let's look at the diagonals, because that's what we're talking about. Required to prove, we want to prove that the diagonals, so that would be AC, is perpendicular to the diagonal BD. So we're going to do it as the dot product. My dot's a little high, so I'm just going to make it a little lower. Okay, so let's find what AC is. So if I can do that, then that BD and AC meet at 90. That's what we're trying to prove. Okay, so AC. Now, if we've got this arrow here, we've got AC, that's an A, that arrow's going that way, that one's going that way. If we use the tracing method, then that would be along there and along there. So we're going from AC, so that's that direction. So we're going tail to head. So it's going to be A plus B. Okay, if you look at the other one, which is BD, so let's look at BD. So I'm just going to do the tracing method on BD. So B is there, that'll be minus A plus B. So it ends up being B minus A. So if I look at the dot product of this, if we want to prove that it's right angle, then we want to prove that the dot product will equal 0. So let's go AC dot BD. So that's going to be A plus B dot B minus A. So when I expand that, I'm just going to make that the difference of two squares. So I'm going to put it the right way around, because then it's easier to expand. The two middle terms will cancel out. So you've got B dot B minus A dot A, because the B dot A and the minus B dot A, they'll cancel out. Now B dot B is the same as B magnitude of B squared, and A dot A is the same as the magnitude of A squared. But this will equal 0, since the magnitude of B equals the magnitude of A, because they are equal sides of a rhombus. Okay, and that proves it. So if they're equal sides of a rhombus, the dot product will be 0. If the dot product will be 0, then that there is a right angle. Okay, so proof 2, prove that the midpoints of the sides of a quadrilateral join to form a parallelogram. So you just get any quadrilateral, we'll call it A, B, C, D. And now if we get the midpoints of those, that's equal to that, that's equal to that, we'll make that 3. And this one here, I'll put a 4 there, so it's 4. So if I join this up, these sides up, what it's saying is that is a parallelogram. So I'll just give these some letters, E, F, G, H. So what we're trying to prove, or required to prove, that's what RTP is that E, F, G, H is a parallelogram. Okay. All right, so just to note, to prove something's a parallelogram, all that's required is to prove that one pair of opposite sides are equal and parallel. That's the easiest way, because you can do that really easy with vectors, because you can just prove, for example, that say FG, vector FG is the same as vector EH. Because when you're doing that, that means that they are parallel and equal. See, if you think about it, if I have two lines that are parallel and equal, and then I join up these here, that will be a parallelogram. So we're just going to use that here. Okay, so let's start. We'll do the proof just up here. So let's start with F. We're going to do F, G, and EF. So in order to do this, let's put in some labels. So let's call AE, we're going to call that A. Okay, that means that EB will also equal A. And AB will equal 2A. All right. We also, let's put FC. So FC, let's call that B. And that will then be equal to BF. Let's call CG. That's going to be equal to C. Sorry, I'll go back on that. We'll call that one C. So we've got this is A, B, B, C, C. And that vector, that will be the same as GD. And then further on that, we can go that AD, AD, not AD, we'll do AH, we'll call that D, and HD, that will be another D because it's a midpoint. So that's the D and that's the D. Okay, so we've just introduced all of our labels. Now, when I did that and I introduced them, the arrows are all going around the same way around the circle. Now, I should have probably, I think I've done, so we did CG. Yeah, CG. This last one here is what I didn't do it the right way around. So that's DH is D, and HA will also be D. They have to go around the right way. Okay. FC. FC. This one here should be BF. That should be FB. Okay, so it's all going that way around. Okay, so now if we go for FG, all right, so let's put an arrow on FG, and I'm just going to make that pink, so we want that arrow. So if we go to the tail and we trace around, FG would be B plus C. And if we look here, EH, if we look at that and we trace that, it'll be D plus A. Okay, so EH, it's going that way. So if I come back the other way, that's going to be along here, which is minus A minus D. So let's go, that was EH equals minus A minus D. Now, what we want to prove that FG is the same as EH. Okay, so we're actually required, we want to prove this equals minus A minus D. All right, so what we're going to do now is, if we trace around the outside of this shape, all the vectors should sum to 0. That's the polygon rule. So if we come here and we go, all right, we're going to start with, let's start with the A. So you go A, E, E, B, that's A, so that's 2A plus B and B, 2B plus C and C, 2C, D and D is 2D. They all have to add up to 0. So 2A plus 2B plus 2C plus 2D all be 0. If you divide everything by 2, A plus B plus C plus D equals 0. Okay, so if we move that to the other side, that's A plus B equals minus C minus D. And that's the proof that we actually wanted to do up here. So which is true? it's true because of the polygon rule. So therefore, FG equals EH. So therefore, it's a parallelogram. FGEH is a parallelogram. If E, G, E and H all go through a midpoint. Okay, so once again we're trying to prove that that's a parallelogram if it goes through the midpoint. So first thing we did is we labelled them as like with two A's, two B's, two C's, two D's. And we used the triangle rule to get this one, which was A plus B. The triangle rule to get this one, which was this is an A plus B, this is C plus B, this is minus A minus D. And we want to prove these two things are equal, and in order to do that, all we did was go around the outside. Two A's, two B's, two C's, two D's. Come back to the beginning, they'll be 0. So therefore, once you've done that, you can see that because they equal 0, when you move this to the other side, that A plus B is minus C plus D, which is the same as FG equals EH, and therefore it's a parallelogram.